Okay, so there's some fun instructions at the beginning of this that you should probably be familiar with.
I do not.
So we're going to start out with the graphing calculator part. It says, before you begin part A of section 2, you may wish to look over the problems before starting to work on them. And the reason why is, it is not expected that everyone will be able to complete all parts of all problems, and you will be able to come back to part A without a calculator if you have time after part B. All problems are given equal weight, but the parts of a particular solution are not necessarily given equal weight, and they go through that in the answer book, how many points you get for doing the different things. You should write all your work for each problem that's being provided, show all your work. That's really important because you get partial credit. You will be graded on the correctness and completeness of your methods as well as your final answers. Yeah.
Why can't we look over?
You can look over, you're going to start with the calculator section on the free response. So you have 45 minutes to do that. When 45 minutes are up, you get a little break, and then you go to part B with no calculator. You can come back and look at part A when you're working on part B. But you can't go ahead and look at part B. You can go back, but you can't go forward. Okay? Because then you have a calculator. You're permitted to use a calculator in part A to solve an equation, find the derivative of a function of points, calculate the value of an integral. However, you must clearly indicate in your exam booklet the setup of your problem, namely the equation, function, integral you are using. So if you do something on the calculator, you still have to write what you did on the test. Okay? So like the very first one we're going to do today says find the area of the region. Well, it's a really simple integral. We don't just type it in the calculator and write down 16. You show the thing that you typed into the calculator. Okay? Unless otherwise specified, your final answer should be accurate to 3 decimal places after the decimal point.
Could I have your attention, please?
Yeah.
A slight oversight, not realizing.
Go home and grab their guns and go on a man.
We're going to find it.
All right, so does that make sense? The instructions there?
Not 6 is from 0 to 1.
Okay, so yeah, let's take a look at the very first problem. And this is a calculator problem. So this first part should be very easy. Let R be the shaded region in the first quadrant enclosed by the y-axis in the graphs of y equals 4 minus x squared and y equals 1 plus 2 sine of x, as shown in the figure at the right. So the first thing we need to do is find the area of the region. So Matthew says what?
Go from 0 to 1.
Okay, so he says 0 to 1, and he is dead in the water already, but he would still get at least partial credit. Okay. No, I like the 0 because clearly the graph starts the left-hand side is 0. But how do you know it's 1? Use a ruler. Use a ruler. You have a mini calculator computer available to you, and your answer is use a ruler, Lindsay? Is this the 1700s?
Grab it.
Type in the equation.
Why can't we just
see where you can assume all you want, and I'm going to assume you're not going to get credit.
Assuming makes an ass out of you and me.
4 minus x squared.
How are they going to see my graph? They're not.
No, but you're going to get the wrong answer if you go from 0 to 1.
And you're going to fail.
And you're going to lose a really easy points if you do that wrong. Okay, so there's the graphs that we're looking at. So we're just trying to find the area of this little region right here. So yes, 0, but then do you guys know how to find that intersection point? Second, trace, 5, enter. Okay, so not, what did you say, 1 point what? And what did I say when I was reading the directions?
1.102.
Thank you very much. Someone was paying attention to at least 3 decimal places. Okay? So you want to have 0 to 1.102.
Yeah, there's got to be a way that people are just going to be like, oh, I kind of create something.
The whole Yeah,
Where
well,
you
they
just
seem made
go to that
perfect for
shaded
us.
area
What did I say?
and click on it and it gives you the area.
Yeah,
There's got
gotta be a way. Okay, and then we're going top one minus bottom one, right?
Right.
But now it's the
So, top is the parabola,
Makes me
4
do
minus
it.
x squared, minus, bottom is the sine graph, 1 plus 2 sine x. Okay, and I've let you guys be lazy this year about this, but this is how you should write your, show your work. Okay, this thing in parentheses minus this thing in parentheses, throw the dx in there just to make the people that grade it think you have some vague idea of what the heck you're doing.
We need to show work on how we get that.
Ooh, good question. Doesn't look like it. It says in the answer book, it says 1 point for getting the correct limits of integration. So you just have to put that down. Right. Okay. So now we can go ahead and do this on the calculator. So 0 to 1.1.
One zero.
Can you write that down
Well, I mean, this is what you write on your textbook. Okay.
Just write it in.
And then we're going to just write down the answer. And then you find- they just need to know that you set up the equal row correctly. If you just write down the answer that we're about to get, 1.764, you're not going to get credit for that. What was it? 4 minus x squared. So lots of
Yeah.
Okay, so,
I'm not an economist.
like I said in the instructions, make very sure you're going to 3 decimals, so 1.76.
That's right.
really good.
That is the correct answer.
It was actually hammered like I said. It was a hammer of this and that. Exactly. That's oh. Stop.
So that's all we have to put?
I'm doing.
Yep, that's all you have to put. And then you get 3 of the 9 points. Okay,
That's 1/3. That's 3.
If we average 3 out of 9 points for.
I just don't do that. Do better than that.
Okay, so the next part says find the volume of the solid generated when R is revolved around the x-axis. So we're still going from 0 to 1.102. But now since we're rotating the thing, what are the cross sections? Since you're rotating it. What shape? Circles.
Yeah.
Okay? So that means we have to do the pi r squared thing. So this is going to be exactly the same, except it's going to be pi times 4 minus x squared squared minus 1 plus 2 times x squared. So it's a pi r squared thing instead of just a regular function thing. Huh? Yep, so you just have to write that down, plug it into the calculator, and you can do that if you want. That seems like kind of a waste of our time. You will get 30.460. Okay?
What about pi?
Yeah, we did it times pi, got that.
So we have to use pi.
You could, maybe, yeah. But, yeah, the reason I say maybe, yeah, I imagine you could. But usually, the thing is, you're going to get a decimal answer times pi, and usually when you have a decimal answer times pi, you go ahead and multiply it out. The only time you leave things in terms of pi is if it's like 16 pi. Or you wouldn't necessarily usually see 9.483 pi, you know what I'm saying? Because you already have some decimals, so go ahead and just bite the bullet. All right, so first one, I would hope that most of you in class could get this. Okay, if you didn't, then big 0 to 12. Second one, I know we start to lose a few people. And then this third one, this is, you know, where things get a little bit trickier. But that's the way these problems are designed. The first part is relatively simple, and then you just sort of weed people out as you go. Okay? But it still is not that bad. Find the volume of the solid whose base is R and whose cross sections perpendicular to the x-axis are squares. So we're still going to go from 0 to 1.102. The whole key to finding these volume thingies is that what you have to take the integral of is whatever the area of the cross section is. And so on part B we did pi r squared because when you rotate it, it's circles, right? So if the cross sections are squares, what's the formula for the area of a square? Right, it just equals to the side squared. Well, if you look at this little graph, how would you figure out what the length of the side of the square is? Like, no,
You rotate, you still rotate.
no, we're not rotating at all. So what we have is this shape like this. You've got Ben's here because we always like to do these things up, so we talk about these. So you have this shape like this, right? This is your region R, and what you're doing is you're just stacking squares on top of this. And so the length of your first square would be this much, okay? And the length of the side of your next square would be this much, and then this much, where it goes, and this much, and this much, and this much, and then the squares are coming out of the board. Okay, so it's just a stack of different sized squares sticking out of the board here. Can you visualize that?
Why?
I don't know, why not? Because it's just
Wait, so-
because.
Go up and down.
Thanks. All right. That's not the next one.
The same question?
So the squares are going that way.
So the squares are going like this. Okay? So they're sticking out like that.
Coming at us.
Priceless. Coming at you live, yeah. So how do you find the length of the side of one of these squares?
Okay.
What would this distance be from here to here?
The dot.
I mean, I think you guys are saying the same thing. It's the top one minus the bottom one, okay? So all you have to do is take the top one again, 4 minus x squared, minus the bottom one, 1 plus 2 times x. And that's going to give you the length of the side of one of these squares. What do I have to do with that? Square. Because that's the formula for my area of a square. Right? Type that in the calculator, get the right answer. Chuckle to yourself.
I got it right. You got 3.671.
You should get 3.671. Decimal didn't really come out very well. Okay?
How do you make this square? How do you do a square outside?
Oh, like how do we physically put this into the pencil here?
Yeah.
Okay, math 9, 0, 1.102. So I'm going to go parentheses 4, is it 4 minus y squared, x squared, parentheses, minus, parentheses, 1 plus 2 times x.
Parentheses, rep C.
Right? What happens? Okay.
And syntax.
Minus x. Okay, so I have to close the parentheses that goes with the x, right? And then I have to close the parentheses that goes with the 1 plus 2 sine of x. You can't tuck a, oh, it won't let you tuck a squared right in there. Okay, so that's gross. That means you have to put another parentheses around the entire thing. So this parentheses goes with the x, this parentheses goes with the
So
whole
you know,
function.
one of these,
I got it.
in front of one plus.
Yeah, and then
Oh,
you,
minus.
right, so then you need parentheses at the very beginning also. You guys know how to use the insert,
Yep. Second, delete.
second delete, and it'll put something in there for you. So that's awkward. But you get that in. Okay? All right, so that's easy, huh? What an easy test this is going to be.
One color.
All right, number 2. A square is inscribed in the circle as shown in the figure at right. So I got a circle. And I've got a square. Something like that. Okay, so as the square expands, the circle expands to maintain the 4 points of intersection. Does that make sense? So they're both expanding, but they're going to expand in such a way that the square is going to stay inside the circle. The perimeter of the square is increasing at a rate of 8 inches per second. So you're going to say that means dp dt equals 8. All right? By the rate at which the circumference of the circle is increasing. Okay, so that means what we need to find is we need to find dc dt. Okay? So give me something I know about the circle and its circumference and all that. C equals 2 pi r. So if we take the derivative of this, dc dt would equal, be careful, 2 pi. But since this is not dc dr, this is dc dt, it's like that implicit differentiation thing, so it's going to be 2 pi dr dt. Okay? So, if we just knew what dr dt was, then we would be in business, because we know what 2 is, we know what pi is, and we just need to find this. You know how you have your little thing and that thing sticking out of your head? I keep seeing how it turn around and I feel like a gray spot there. You look like, so can you give me a relationship between, because we know the perimeter of the square, is there a relationship between the perimeter of the square and the radius of the circle? Are you playing golf? Why did you just shout out 4 randomly? Oh, okay, so the perimeter of the square is equal to 4 times the sides. Okay, so that would give us maybe a way to get something going there, but we need the radius of the circle. So go to the picture. Yeah, we need the Pythagorean theorem here, because we know the radius of the circle is that right there. And then we got that going like that, right? So, how does that all work? We call this S for Lingstein, so this little piece is going to be S over 2, and that's going to be S over 2, right? So R squared equals S squared over 4 plus S squared over 4. How do you feel about that? Not okay? Not okay. Which would be 2S squared over 4, which would be S squared over 2, right?
So we need to show all this.
Well, do you guys have the answer book in front of you? It says 2 points for the equation relating the perimeter P and the side X of the square. So that is this thing that Lingstein gave us, so you get 2 points for that. 1 point for dp dt. Did you do do that yet? Yeah, 1 point for dp dt, 1 point for dx dt. We're using s, so we're going to get there in a second. And then 1 point for the answer. So, okay, so r squared equals s squared over 2. So what do we do with that?
Square root.
Square root of it?
Yeah.
Okay. Sure. So r equals s over root 2. Good with that. Now what? Remember what we're trying to do here is we're trying to figure out what the RDT is, because all we need to do is plug that in and then we can get the answer. So I'm going to take the derivative of this. So the RDT equals, what is the derivative of that? What's that? Yeah, it'd be 1 over root 2. But again, we're doing sort of the implicit differentiation thing, so it'd be 1 over root 2 ds dt. Okay? Yeah, it means we're getting out of hand here. So now we know what the RDT is, but now we have this stupid ds dt thing in there, which we don't really want that either. So we haven't used this yet, or this yet. What's the relationship between these two things? This is what? So dp dt equals the derivative of this, which is 4 ds dt. Okay? And we know dp dt equals 8. So I can plug an 8 in there. So 8 equals 4 ds dt. So what does ds dt equal? 2. Right? Okay, so put a 2 in there. So the RDT actually equals 2 over root 2. So this is going to be 2 pi times 2 over root 2, which would be, what? 4 pi over root 2. And then I don't know how they have the answer. So you could, what does that come out to be here? Simplify that. So they have it that way. It seems like you could probably leave it like this, like Lindsay and I were just talking about, but this would be a case where you could have a pi in there. Hopefully they wouldn't be gross and make you rationalize the denominator. So they get 2 root 2 pi, whatever. Or you can do the decimal. Okay? Totally awesome? That was kind of a little rough, wasn't it? But you could find a few points in there, right? Just write down some crap, draw a picture, throw Pythagorean theorem in the mix, take some random derivatives, and then looks a little panic right now, it'll be okay. Alright, then it says that the instant when the area of the square is 16 square inches, find the rate at which the area enclosed between the square and the circle is increasing. So they want us to find the rate at which the area enclosed between the square and the circle is increasing. So we better come up with a formula for that first. What's the formula for the area of the circle? Okay, pi r squared. But we want the area in between that and the what? What's the formula for the square, for the area of the square? Well, but we're going to do the regular thing first, and then we're going to, what's that? Yeah, we're going to want it in terms of r.
S.
So it's, the area of the square is s squared, right? And so if we look back to this work right here, s squared would be 2r squared, okay? So that'll work out for us. So it'll be pi r squared minus 2r squared will be that area, okay? So, okay, so if it wants the rate at which the area between those is increasing, rate means rate means derivative. Again, this is a implicit differentiation kind of thing, because we've got a third variable t, so it's going to be 2 pi r dr dt minus 4 r dr dt, like that. Now we just have to plug in some crap.
So far, it seems like that's showing.
Just, yeah, plug in some. All right, so it says this is at the instant when the area of the square is 16 inches. Well, if the area of the square is 16, what's the side of the square? 4. Okay, so if the side of the square is 4, what's the radius of the circle? If you go back here and say the side of the square is 4, 16 divided by 2 is 8. So the radius would be the square root of 8, which is 2 root 2, right? So we go 2 root 2. What is the r dt? I'm pretty sure we figured that out at some point back on the other page, don't you think? Is there a dr dt on that page somewhere?
1 over.
Where is it?
1 over square root.
Where is it, Lingsing?
Next to the square root.
Next to the circle. Oh, right here. dr dt. Okay. Is 1 over
The one
root.
circle.
What's that?
The one circle.
No, you need that.
Right here? Yeah. Okay, so dr dt is 1 over root 2 times the s dt. But then what's the s dt at this instance? Do we know?
2.
How do you know that?
The volume.
This is at the instant when the area of the square is 16 square units. That's, oh, okay, so we're still going to go 2, you think? All right. Oh, I see. The RDT, that's what you're saying with circle. So you're saying leave that right there?
No,
Oh, I multiplied that already? You're right. So the RDT was 2 over root 2. Yeah, that's right. Okay. Nate, feeling good about things?
Whatever.
Okay, so dr dt was 2 over root 2. Good chance we're going to end up getting this wrong in the end anyway, just to make things more exciting. So then that's going to be 4 times 2 root 2 times 2 over root 2. So, bam, 2, 4, 6, 8 pi minus, bam, 16. 8 pi minus 16. Ooh!
9.1. Oh, that's right.
Yeah, that's right.
9.1.
Do it again. You guys all got that, right?
That was all.
You saw. Okay. Should we go one more?
Yeah.
Got the brain space for it?
No.
That last one was a little rough.
Maybe we'll find it.
Okay, one more. Oh yeah, for sure.
Oh, I can do this one though. Just throw a 1 in there. Kind of.
Okay, number 3.
It's never that easy.
Never that easy.
No, you do though. Wait, how do you do that?
Exactly.
How do you do 1 to 1? It's 0. It's 0.
Is it 0? It's 0. Matthew got it. All right, so the first thing they want us to do is evaluate f of 1. And like Matthew said, we can do that. You just plug a 1 in there for x. So you plug a 1 in there, square root of 1 is 1. So they're asking you what's the area under the curve 2t minus 1 over t plus 2 from 1 to 1. So you've got a width of 0. So you got no area. The answer
Yes!
is 0. Okay?
Wait, do it shorter.
Yes, just that. Just what I wrote.
You're gonna be the guy.
Okay? No, you're not going to do that guy.
He might be.
He's not good.
With a friend.
All right. So B, now it says figure out what f prime of 1 is. So take the derivative of this crap, right?
Take the derivative of that big.
Okay, so the derivative of the integral is the same thing. But you have to times it, get you remembered by the, you have to chain rule, so you have to times it by the derivative of that top thing. So the derivative of x in this case is going to be 2t minus 1 over t plus 2 times the derivative of the square root of x is that chain rule discussion we've had a few times, which is going to be 1 over, whoops, that should be it. Right? Yeah, we should have x's in here. So root x. These should all be x's. What's that?
Should it be root x or x?
It'd just be x. Okay? Pretty sure. Hope so. But, I don't know, it's just like, why did they put root x? Oh, because we're plugging it into the, yeah, okay. All right, thank you. Okay, yes, so what Tyson said is right. When we were taking the antiderivative of this, you would plug in the root x into the things. So this becomes 2 root x minus 1 over root x plus 2, and then times 1 over 2 root x, because that's the derivative of that. You good now? Yeah, okay. So that's your formula, and then you just plug in 1, because we want to figure out what f prime of 1 is.
0.
No.
It's not really that easy.
Yeah. So you plug in 1 there, you
1.
get 1, 2, yep, that's going to be 1 on top over 3 times, plug 1 in there, you get 1/2. So that is 1/6. Okay?
0.
Good thing this is shout out numbers. Okay, C, find an equation for the tangent line to the graph of f at the point where x equals 1. Okay, well we already have all the information we need in order to solve this. You need a point, okay, and we already figured out that point. We figured out that when x is 1, y is 0, so we know our point is 1, 0, right? And you need a slope. Since the derivative is the slope, we figured out the slope is 1/6. So as long as you can recognize that those things are those things, it's a very easy problem. So the question is just testing, do you understand what the heck it is that you just did? So y minus 0 equals 1/6, x minus 1, y equals 1/6. Okay? Unless they indicate it, I don't think you have to. Okay, then finally D says on what intervals is the function f increasing? Nope.
First derivative.
First derivative. What do you need to be true about the first derivative?
0.
Positive. So here we have the first derivative right there. Okay? So we just need to figure out where that is positive. How do you want to do
Is the
that?
bottom or down?
Yeah, I mean, if you want to do it algebraically, then you could do that. You could multiply the top times, top times the top, the bottom times the bottom, and then just mess with the top. But I like what Matthew said, since we have access to calculators, we're just going to graph it. And then what are we looking for in the graph? Nope. We want where the derivative is positive, right? So we want to know where this graph is above the x-axis. Okay? So I don't even know how to graph this thing. Maybe it would be better to distribute it first. You know what I mean? 1 times this is just going to be 2 root x minus 1. And if I multiply both of these by 2 root x, that's going to give me 2x plus 4 root x. So you have to go parentheses there, parentheses there. Can someone tell me what I need to do there when I graph it? You ready? So what am I graphing? 2 root x minus 1 on top. Divided by, what was it on the bottom? 2x plus 4 root x. Okay, so if you look at the graph, you want to know where that's above the x-axis, which looks like this over here, so I just need to know where did it cross right there. Yeah, I know you can't really see it, but it doesn't matter because the calculator knows. You guys know how to do this? Second calc, no, we're not zooming, we're looking for the zeros of the graph, where it crosses the,
Trace.
no, trace gives you the inaccurate. So left bound, so I need to name a number to the left of where that crosses the x-axis. What's the number to the left of that?
Can you just move over?
Well, but I need to be to the left of it, so I'm gonna go -1, and I need to be to the right of it, so I'm gonna go 5. And then my guess is 1, so 0.25. So it's increasing from 0.25 and above. So that almost would have been easier to solve algebraically with the top equal to 0. Do it top 0.25 also. Okay?
Cake.
Cake!
Got it.
Easiest stuff ever. We did a whole section right there.